Welcome to this new video about limits. So here we're gonna try to find some limits using the graph of a function f of x. The first example is this function, and we're gonna compute the limit as x approaches 0 of f of x, the limit as x approaches 1 of f of x, and the limit as x approaches 2 of f of x. So let's start with the first one. When x approaches 0, the 0 is right here, and you're gonna approach 0 when, if it's not specified 0 plus or 0 minus, you're gonna approach your 0 from the two sides, the left and the right. And if you look to your graph, the corresponding output on the graph when x approaches 0 from the left is 1, and the corresponding output of the function when x approaches 0 from the right is also 1. So the limit of f of x as x approaches 0 is 1. Now move to the second one. When x approaches 1, so here you're going to approach again from the left and from the right, okay? And if you look to the graph, it's going to the common point here, which has a y coordinate equals 0, because a limit is always a y coordinate. It's the output of the function, okay? So here the limit at 1 is 0. And for the last one, when you approach 2 from the left or from the right, again here the graph is going to the same point, which has a y coordinate equals 1, okay? So your limit at 2 is 1. Now let's move to a second example. Here we have to compute the limit at -1, at 0, and at 1. Now, if you look to your graph and you try to approach -1 from the left, it means to the left of -1, the graph will go to this point, okay? And this point has a y coordinate equals 0. So if you approach from the left, the limit is 0. But if you approach from the right, the corresponding graph is going to this point, and this point has a y coordinate equals 1. So what happens here? You have a limit to the left of -1, which is 0, and a limit to the right of -1, which is 1. So you have two different values, two different one-sided limits. And in this case, you conclude that your limit does not exist. A condition for a limit to exist is that the limit to the left of the point and to the right of the point is the same. So if it's not the case, the limit does not exist. So we conclude here that your limit at -1 does not exist. For the second one, the limit at 0, here is the x equals 0, and when you approach 0 from the left or from the right, the graph is going to this common point. So the limit exists, and this point has a y coordinate equals 0. So your limit at 0 is 0. Now for the last one, the limit at 1, if you approach the 1 from the left or from the right, the graph is going to a common point again. This point has a y coordinate equals 1. Therefore, the limit exists and it's equal to 1. Now let's continue with the third example, in which we have the limit at -infinity, at infinity, and we have the one-sided limits. It means the limit at the left of 0, to the right of 0, and so on, okay? So let's start with the first one, the limit when x approaches -infinity. And here, you try to identify the branch of the graph which corresponds to x approaching -infinity, okay? So when you approach -infinity on the x-axis, you are going to this direction, and the corresponding graph is increasing infinitely here, okay? So your limit at infinity, at -infinity, sorry, is infinity. Now, the limit at -1 minus, it means to the left of -1. So here we are to the left of -1, and we can see clearly that our function is also increasing infinitely. So the limit to the left of -1 is infinity. Now, if you look to -1 plus, it means to the right of negative 1, for this limit, you have the graph which is decreasing infinity. So it decreases to negative infinity. So the limit to the right of negative 1 is negative infinity. Remember that I said the condition for a limit to exist is that the limit to the left and to the right of the point are equal. Since we have here the limit to the left of negative 1 is infinity and the limit to the right of negative 1 is negative infinity, therefore the limit at negative 1 does not exist. We can't speak about the limit since the one-sided limits are different. Now let's move to 0. I'll just erase this. So here, when you approach 0 from the left or from the right, the graph is going to the common point which has a y-coordinate 0. So the limit to the left of 0 is 0, the limit to the right of 0 is 0, and the limit at 0 is 0, since we have two one-sided limits which are equal. Okay, to the left of 0 and to the right of 0 are 0, so the limit at 0 exists and it's equal to 0. Now let's move to x equals 1, and here we are going to compute the limit to the left of 1, sorry. So when you go to the left of 1 here, the graph is going to this point, and this point has a y-coordinate equals 1, therefore the limit to the left of 1 is 1. Now if you look to the limit to the right of 1, here the corresponding graph is here. Okay, and this point has a y-coordinate equals 2. So the limit to the right of 1 is 2. And since these two one-sided limits are different, the limit at 1 does not exist. The last limit to compute is the limit at infinity. So you try to increase your x infinitely here. And if you look to the graph, it's a constant. Starting from x equals 1, the function is constant. So the limit at infinity will be also equal to this constant. It's equal to 2. Okay? So thank you for your attention and see you in the next videos.